Hi everyone! In today's lesson we will be studying partial fractions, which is a small topic in the IB Math AA high level in Algebra. Now, what are partial fractions and why we apply them? We will clarify all of that in today's lesson. First, partial fractions is about breaking down large algebraic fractions like this into smaller and more manageable algebraic fractions. How do we do that? First, we factor out the denominator fully if it's not factored. So here, the denominator is a quadratic. We need two numbers, add up to -3 and multiply to -4. They will be easily -4 and +1. So when we factor, the denominator will have 4x minus 26 divided by x minus 4 times x plus 1. Now, since we have here two factors in the denominator, this fraction will be broken down into two smaller fractions. So this is identical to a constant number a divided by the first factor x minus 4, then plus the second constant number b divided by the second factor x plus 1, as we see here. Now, how do we find the constants a and b? It's all about finding a and b. So to find a and b, first we'll add these two fractions up as if we know a and b. Like, how would you add these two fractions if they have different denominators? Of course, first you will make their denominators equal. You will multiply here a by x plus 1 and b by x minus 4, and the denominator will be the product of these. So this will be like this: a by the other factor x plus 1 plus b multiplied by x minus 4, and both will be divided by x minus 4 times x plus 1. Now notice that here the left hand side or fraction is identical to the right hand fraction. So these are identical, and since they have the same denominator, then they must have the same identical numerator, which means this is identical to this. So now we will write 4x minus 26 identical to a multiplied by x plus 1 plus b times x minus 4. Now, of course, later when you become expert and do more solutions or more questions in this partial fractions, you can skip writing this fraction. Because always we know that when we make the denominators equal and multiply a by x plus 1 and b by this, just you can write the numerators only, because the denominator is anyway equal and they will cancel. Now, how will we find here a and b? First, keep in mind that this is not an equal sign. This is an identity sign, which means these two sides are not only equal, they are identical. So they are always correct or equal to each other, no matter what x you replace in. So we can replace x by any number, but conveniently, this is how we replace values of x to find a and b. See this bracket, x plus 1. What value of x makes it 0? Of course, -1, because -1 plus 1 will be 0. That's why I will substitute x by -1 in both sides. Here, if you replace x by -1, you will get -30. On the right, this will be 0. 0 by a, 0, so you can ignore it. Here you have -1 minus 4 will be -5 multiplied by b. So b multiplied by -5. Easily, if you divide -30 by -5, b will be 6. Now, in a similar way, we will find b. This time, we will replace x by 4, because 4 makes this bracket 0. 4 minus 4, 0, then b will be cancelled. So replace x by 4 in both sides. Here you will have 4 by 4, 16, minus 26, -10. Equals a, 4 plus 1 will be 5, and this will be 0, ignore it. Easily, a will be -2. since we found a and b, it's nearly done. Which means now this fraction here can be rewritten like this. I'll erase a and b and put, for a, I will put -2, and for b, I will put 6. So that's it, it's done. We broke down this fraction into smaller partial fractions. Now, in case you need to check, if you add up these two fractions and make the denominators equal and simplify, you have to get the same as this. Now, why we apply partial fractions in the first place? Because of two reasons in the IB. If you've studied calculus, or if you haven't, you will study calculus later and integration, you will see that later you might be asked to integrate a fraction like this, where you cannot do it directly because no rule to integrate this. Instead, you break it down to smaller fractions like these, where you can easily integrate them, and when you integrate these, they will be logarithms. Another reason, if you've studied the extension to binomial theorem in the IB high level, you would know that you can make these denominators power of -1 when you send them up and do the binomial expansion on them directly, where you cannot do it directly on this fraction. I hope that you have found this video helpful. Please hit the like button and consider subscribing to the channel. Thank you for watching.